So inverse trig function, we have to recall first of all what is an inverse function.
What is it?
Right? Inverse function, essentially, a function is, it takes an input as a value of x, right? And it gives you an output of y, right? So it takes something in from the domain and gives you a return of y, right?
Yeah.
Now, if it's an inverse function, it will take that y value, okay? And if you put that y value inside this inverse function, it will return back
X.
what you gave, right? So, you know, if this is a domain, this is a range, here's your x value, you get the y. That's the function. The inverse function is it somehow knows exactly how to undo, how to trace back where the y came from.
Yeah.
Okay. Now, not all functions have an inverse function. So this is a function. Let's say you have, so it's a function as long as you have like all the x values being assigned to a unique y value. Okay. So this x actually being assigned to only one y value, not unique, sorry, one y value. So look, here's a x1 that gets assigned to a y, okay? Let's say y1. This is domain and range. So that's what the function does. It takes x1 and it delivers you to y1. Okay. But it can also take x2 and also deliver you to y1. But if you try to go backwards, how do you go back?
Doesn't work. Plus minus.
Well, yeah, exactly, right? It doesn't work because it came. We don't know. We could go this way, or we could go this way, right? So we don't know. We can't say where it came from. Okay. So this is actually a function. It's called a many-to-one function. Right. But it does not have an inverse. Now, unfortunately, trig is such a function. Sine graph. Think about it. Here's a graph of sine. Let's say you have a particular y value, right? So which y value, so which x value gives you this y value on this graph? That's the question. But there's infinite,
Yeah.
right? So when we talk about inverse function, we can't talk about it using the whole sine function. We have to limit our sine function. Yeah, so we have to limit it. And here's how we limit it. Okay. So notice that the sine function, if you drew it like this, yeah, I can't go back down. If I go down, I'm gonna get two x values for every y. So don't go down, and from here we can go down this way, right? So really, the sine curve looks like this, and it goes down and it goes up, right?
Yeah.
But we only take this part of the graph. Right here. So we restrict our domain from minus pi over 2 to pi over 2. Okay, so if essentially if the function is sine x with restriction that x is between minus pi over 2 to pi over 2, then we can say there's an inverse function. And usually we write it either this way or this way, arc sine x. Okay, so you see this is more popular because it's on the calculator.
Yeah.
But sometimes this is better because this is kind of confusing with the power of -1. Okay? So just to clarify, you have to understand that when you see this symbol, right?
Is it between?
Okay, so when you see this symbol, this actually means something that's equivalent to this. Okay, they mean the same thing. Since this is a domain and the range is from -1 to 1, for the inverse function, the x is going to be between -1 to 1, and the inverse function will be from negative pi over 2 to pi over 2. Now here's how it's going to look. Here's pi over 2, right? So pi over 2, so this graph is a little bit off scale right now because this is 1 and pi over 2 is actually bigger than 1.
Is it?
Yeah, because 3.14 divided by 2. So let me actually redraw this just so that my picture will look more balanced. Okay, so let's say that's 1 and negative 1. Let's say this is pi over 2. So the graph will look something like this. Okay. Now if you were to draw the inverse function, the pi over 2 will go on the y-axis like this. Negative pi over 2. And then this will go on the x-axis. Okay. And it's also a reflection on y equals x, which is a straight line that goes like this, right?
Yeah.
So let me. Okay. So look, it's gonna start from here, where they meet here. Yeah, it's gonna meet here. It's gonna go like this, and it's gonna meet there. So it's gonna go like this. So because the way it looks, right? I'm not gonna ask you to draw it too much, but you just have to understand that there is a picture, right? And because of the picture, the domain. Notice the domain is from -1 to 1, and the range is from -pi over 2 to pi over 2.